So this problem says, suppose a manufacturer of widgets has fixed costs of $6,000 per month. So in any given month, they have to pay $6,000 for like rent, employee salaries, and stuff like that. Now, there's a variable cost as well. It costs them $10 to produce every widget. And they're going to turn around and then sell the widgets for more than it costs them to make. They're going to sell them for $20 each. Let's find the cost function. It didn't ask for that, but I'm just going to do it as an example, okay? So the cost function, it's C of x equals 10x plus 6,000. Now in this particular problem, they want x, the number of units, to be represented by a different letter. They want n. In math, little n and capital N are considered different. Okay, it helps us like sort of have more letters to work with if we allow a difference between them. So we use the letter R for revenue. That's the money that comes to the company, not taking into account any losses. This is cost function. This one's called a revenue function. Okay? Yeah, profit is a little more complicated. When it comes to profit, we have to take both the revenue and the costs into account. We find it by subtracting revenue minus costs. So my answer to A here is going to be 20n. But when it comes to my answer for B, for the profit, we want to subtract this formula minus this formula. Okay, so it's going to be 20n, that's the revenue, minus, and then you have to put parentheses around your cost function, because the whole function has to be subtracted. So that will be my answer for B. Okay, now let's see what they ask next. They say, what if you had 200 widgets to sell? What would be the profit at that number of units? So profit is a function of the number of units. Yeah, 20 times 200 minus 10 times 200 plus 6,000. I get negative 4,000, which is really bad for the company. Okay, they're going to have a loss if they were to only produce and sell 200 widgets. Apparently the costs would outweigh the revenue. Now we can graph these types of problems. So just go to Desmos. We want to be able to type in our cost, our revenue, and our profit. So the costs, I said, were going to be 10n plus 6,000. Now you're going to have to probably zoom out to see this. Okay, you want to scale your axes by clicking the wrench, and we don't need to go that far with the X. This is a little bit better picture here. Now let's draw the revenue next, which was 20n. Now what we're looking for here is some important points on the graph. We see here that there's a point of intersection. That is called the break-even point, because at that point, your profit is 0, because your revenue and your costs are equal at that point. Okay, if we look to the left here, the costs far outweigh the revenue. Like there, you're paying $6,000 in fixed costs, but you're not making anything because you didn't make any widgets yet. If we were to go somewhere, let's say like with a production level of 1,000, here we see that the revenue outweighs the costs. The revenue here would be $20,000, but the costs would only be $16,000. So that company would be doing well there. They'd be making $4,000. All right, but that's an important point, the intersection of the two. We can also graph our profit function as well. And this is where we just subtract the revenue minus the costs. So the purple here represents the profit for the company. As we can see, if they are to make 0 units, they would have a loss of $6,000. That wouldn't be good. If they were to make 600 units, that would let them break even. If they were to make 1,000 units, then they would make $4,000. Okay, so if the profit is negative, that's bad for them. If the profit's positive, it's good for them. All right, now, in order to solve for the break-even point, find the number of widgets the manufacturer needs to make in order to break even. One approach is to let your C of n equal your R of n. Let the costs equal the revenue. Okay, so if we go back to the cost function, so 6,000 equals 10n. And therefore, 600 is n. That's exactly what Desmos had showed, that we would break even if 600 units were made and sold. The other way to do it, though, just to be aware of this, is to set the profit function equal to 0. Okay, now if we go back to the profit function that we had, it was this. You want to now set that profit function equal to 0 so that we break even. You want to make no profit. And then solve that. If you solve that, I'll tell you what it's going to be. N is going to be 600. Either way is valid.